we go. That should be running. So, I had the great luck of meeting Mike Engelhardt at Electronica 2024 in Munich. So, welcome Mike, thanks for doing this with us. And I'm very sure most of my friends and viewers would be extremely glad to hear what you have to say. So, I guess we can start. So LTspice was released back in the 1990s, and from what I've heard and from what I've read, it was an internal product, internal to LT. But for some reason, LT and maybe you decided to release it to the public. Is there a specific rationale behind just releasing it for free without having to pay for it?
So, with my goal with LT, or my idea with LTspice was, it was much more profitable to give a spice simulation away, spice simulator away, than to trying to sell it. At the time I was writing LTspice, so at the time I had the idea to write LTspice, an EDA company was making about $2 to $3 million a year on their spice program. And they told me that in the interest of discouraging me from trying to do it, because we make so much money we can't possibly compete. And I'm thinking, $3 million a year in California isn't very much money. So I would instead, I could write the same program, and instead of trying to compete for a market of $3 million a year, I would use it to sell $2 billion a year in NICs. It was just much more profitable. So LTspice was, I mean, nobody wanted LTspice, even Linear Tech did not have LTspice. They wanted to do simulation as a check of a circuit synthesized in Excel. And I said, no, you have to just let people use this thing any way they want, and they will develop their intuition on electronics, and their intuition will include your products, and those are the ones they're going to buy. So that's what they want to do. That's much more profitable than trying to sell a spice program. So that was LTspice's business model. It was very successful. It operated in plain sight, and nobody knew what we were doing. Why are we giving this away for free? What's going on here? Well, it's because I was selling $2 billion a year in ICs instead of trying to make $2 million in royalty fees. So that's how LTspice worked. There was a problem with the business model of LTspice, and that is that it was only allowed for simulating parts of Linear Tech products. Okay, you couldn't, other semiconductor manufacturers would hear from the legal department to try to promote their products in LTspice. And that meant that LTspice could never be the ultimate standard of everything, because you'd always need other simulators. In QSPICE, we fixed that problem. Corvo was given QSPICE to the engineering community as a way of introducing themselves into new markets. Corvo has always been mostly house accounts, direct sales companies doing cell phones, and now they're diversifying their product line, and they're going to give away a better simulator than LTspice, and everyone is even allowed to use it, even competitors. So that's the business side support.
I see. So it was a very clever marketing ploy to get people to buy LT stuff.
Well, thank you. I appreciate that. I'll take that as a compliment. I think of myself as a technical person, but I guess if marketing people drive better cars, so I'm going to just take that as a compliment. Okay?
Definitely. Well, it did work. I think we like using LT chips. They are very good. I tell you that much. And the spice motors are actually they work. They are fast. They are reasonably accurate. Yes, although they are rather expensive, but I don't think that's your fault. That's LT management stuff. Anyways, I don't think I've ever heard you mention if there was ever a team behind LTspice, or if it was just a single effort on your part. So was it a group effort, or was it something you did in its entirety?
For the first 10 years of LTspice, I denied having written it myself. But in fact, I just wrote the whole thing myself.
Okay.
Right. And not only that, I actually made the majority of the switcher models in it. When I was with Analog Devices, up until the time I left Analog Devices, most of the switcher models were made by myself personally. that that has a nice piece of follow-up from QSPICE, because in having modeled hundreds of switchers, having done implementing hundreds of switch mode simulation models, I thought of a better methodology and modeling language. So in QSPICE, it's 10 times easier to make a model in QSPICE than it is LTspice, because it just is a better mix of the simulator.
I see. So you basically wrote the entire.
I wrote the whole thing. It's
Back
my
end,
fault.
front
It's
end,
all my
UI.
fault. The simulator, the waveform viewer, the whole thing at the moment.
That is quite
It's
admirable.
it's all my fault.
That's fine. Well, I think in 2024, such an important and such an extensive piece of software would have not been written by one person, by an entire team. And I think you know how that goes. If there's a lot of people responsible for it and there's management pulling the strings, and then it doesn't really end up, it doesn't have a vision necessarily, because LTspice, I've been using it for a few years and I can see that it has a very clear vision.
Yes.
It is almost like I can hear your thoughts when I'm using it. Like,
Thank you. Yes.
you
Thank
want
you.
it to be used in a certain way, and that is made very clear in certain choices related to UI and simulation commands and stuff. So it definitely has the feeling that it's been written by one person and it's been written in a way that has satisfied them, so to speak, to a large extent.
There's another aspect to this that people miss. You think that something as big as QSPICE, now it's really just QSPICE. QSPICE is a much better simulator. It's the only thing I really like to talk about. And people look at QSPICE with using the GPU for the graphics. It's using gamer technology for the simulation. It's a big deal, and people would normally look towards a group of maybe a dozen people who write something like that. But there's an aspect of software project management that people miss. Now, there's this 80-20 rule, that 80% of the result is from 20% of the effort, or 20% of the people. We've come to accept that, okay, that everything, that for different reasons, everything basically follows the 80-20 rule. People accept it. So if you have, 10 people, only one or two of them is actually doing, one or two of them doing 80%. But what people miss is it applies to everything, including the 20%. So if you have 100 people, 20 of them are doing 80%, but of those 20 people, only 2 are doing almost everything that they do. So you don't need a team of 10 or 20 or 100. You just need the right one person.
Makes a lot of sense.
And people miss that. So yes, when people shouldn't wonder how can I compete with a group of 100 people? No, the question is how can 100 people compete with me? That's what they can't do. And people miss that in software engineering.
That's extremely true. So it is worth spending a lot of time and money finding that one right person that, dumping a lot more money, getting 10 people to go
Yes.
10% of the work of that quality. The word management is very clearly written here. I think you already mentioned that as the answer to the first question. What exactly was the atmosphere at LT like back in the day when LTspice was first developed and released? What did management have to say about that?
Well, okay, like I had said earlier, that they didn't actually want LTspice. They were interested in simulation because they had an Excel-based tool for synthesizing circuits, and they wanted to check the results of the simulator from. They wanted to check the results of I'm confused by the screen. That was very distracting to me. Sorry. So they only wanted to move into synthesis in order. They wanted to move into simulation to check their synthesis, and they didn't want LTspice. I wanted to give away a free unlimited spice program because I thought that would be the most profitable thing to do, and I thought that's what they should do. But I had to hide that from management. They didn't want to know that. my peers, which they thought they were scientists, people who were application engineers, they thought that was an incredibly bad idea because they didn't want to confuse customers with all these details on how to design these circuits. They just wanted to give them fixed schematics that you can't edit. And I said, no, that's not what you want to do. And it took months to convince them otherwise. Now, one very good thing about Linear Technology Corporation, and Linear Technology Corporation is a great company. It's a great company to work for. They did accept entrepreneurial suggestion, okay? So eventually they listened to me, even though my peers didn't want this thing. And I can still, to this day, clearly remember the day the decision came down. It was at the end of the workday. Most people had come home, had already gone home, and my boss pulled me off to the side and told me that Bob Swanson had decided that it was going to be okay for me to release this as a free, unlimited, LTspice program. And I solemnly accepted that decision, silently went home, closed the door behind me, and fell on the floor laughing. Because I knew I was going to be rich and famous at that point. There was nothing anybody could do.
It's the year 2024, and here we are.
Yeah, and I just...
and this was back in the 1990s?
That was in 1999.
1999, 25 years exactly.
Yeah.
It's been a while.
So I knew it was the right thing for them to do, but I knew it was really the right thing for me to do. So.
That was very clever on your part. I'm not sure if marketing would have come up with such an idea.
No, marketing didn't. Well, okay, the way most semiconductor manufacturers present their products is they don't say, this is how you do this is how you figure out this is how you do the engineering here. They just say solution, 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 solution. They don't have, here's how you figure out this is how you figure out this is how you figure out that. It very much goes against the grain of the way all semiconductor manufacturers sell their products. But Linear Tech was doing broad market parts, and I was letting people figuring out how to apply parts in ways that in-house application engineers never thought. So it was a good fit from from the mechanics of placing products, and it made a lot of it was very effective.
Yeah, I think the decision was very far ahead of its time. We knew exactly what people who actually use the ICs wanted. Yeah. I have seen this general trend where people within a company, the people who make the ICs, can't exactly come up with the most creative applications, but the users, and not necessarily engineers developing a product, but just people doing electronics for fun, as hobbyists, they came up with extremely creative ways to use certain chips. So I think LTspice does encourage that to a large extent. There was this Japanese person who used a 555 timer as a boost converter to charge capacities. You had to lower the two thresholds enough and use it as a hysteretic controller of sorts. And that was simulated in LTspice, by the way.
I've actually, there is an application for using a 555 timer in boost conversion. I've actually used them in the 1980s in oil exploration. The nice thing about a 555 timer is that there's no thermal shutdown. It will just keep running until it burns up. And so if you have to build a circuit with a service temperature of 200C, you could probably screen 555s to find one that will work at 200C. Get yourself a bipolar one that will work at high temperature. And the algorithm is very simple. I didn't really use the 555 in a way it wasn't intended to be used. It was used as a monostable, but it would it was a flyback, and the input was an asymmetrical half bridge. So you turn two transistors on and take the primary and connect it across the input rail, and then you would turn those off, and it would ring. And once the current had run down to zero, then you turn it off. So it was like a resonantly switched converter. And then all that energy in the tank circuit would be discharged into the output capacitor, into the output coil, and you'd look at that output current to go down to zero. Once it turned down to zero, you'd wait a few more microseconds to let the diode completely reset, and you start a new cycle. And with that method, I could convert 300 watts at 200 C. I could take 500 volts and convert it to 2500 volts. It was used in oil exploration.
So it's almost boundary mode.
Yes, it was boundary mode, exactly.
That's almost exactly how the LT3750 works. That's been one of my favorite LTICs.
Yeah, I don't remember the linear part numbers anymore.
It was a capacitor charger.
Okay, yeah.
Yes. I've had some fun simulating that with LTspice over the last 2 weeks. I just discovered the power of the measure command. So you set the circuit up, step per ramp, and you set it up to measure the pulse width, well, not necessarily pulse width, but the duration of charging. You plot that against the parameter you've stepped through, and it's quite wonderful. And I just discovered that you can step through 2 parameters at the same time, and measure still detects them, and you get multiple plots of different colors.
Yes.
It's quite cool.
Yeah.
It really helps with optimization without having to go through all the math and stuff. It's just very quick. It's amazing. You did mention at a talk in 2023, I don't know if the talk was in 2023, but there was a YouTube video from around that time where you mentioned that it's much easier and much more intuitive to step through component values than to try to do all the mathematics yourself. It makes a lot more sense.
Oh, yeah. I mean, so the whole point of simulation is to develop your understanding of the circuit, so to nurture your intuition, so you come to an intuitive understanding of what all the parts do. And so the main thing you do is step component values and see how your circuit changes. You can change component values. It goes a little bit against the way some people think of hard science, because I actually think of intuition as being the most important thing. And some people don't agree with that, but I can actually prove that intuition is the most important part of engineering. I can prove it. All you have to do is think of the state of Europe 1,000 years ago. Okay, so you had these people living in cities, and they had to defend their cities from other people that wanted to come in and take the things and the food and the people inside the city. So they built walls, and they would make machines to defeat these walls. Well, some of these machines were very primitive, like a ladder on wheels that you shove up against the thing. You hope you can't get to the top of the wheel before you set it on fire. Some are very simple, but some are pretty complicated. Like a trebuchet. A trebuchet is a very sophisticated instrument, actually. It was made 1,000 years ago. A counterpoise trebuchet. Well, you can look at that counterpoise trebuchet and say, yeah, well, it's all F equals ma. You can't push a rope and you can't pull water. That's true. But Isaac Newton came 600 years later. That machine was built with intuition. There's no other explanation.
That's true. Well,
and so that's my proof that intuition is the most important part of engineering.
I definitely agree. I have to admit that I'm not very mathematically inclined. I've struggled with math basically all my life, but it helps to have an understanding, and that understanding is much more abstract than a solid mathematical formula, but it does help you. You do this and you get this as the result, and that's something you know inherently, and you don't have to prove that with math. So I know exactly what you mean somehow. So the next question would be, I guess this has a little bit more to do with you going out of LT and joining Quavo. So what exactly were the origins of QSPICE, and why did we not get an LTspice in 18? 17 was the last one.
Oh, okay. So, I left. So basically, analog devices buying linear technology is one of the best things that ever happened to me in my life. Okay. I did. There was a document leaked to me that showed them them moving away from me. They wanted to get rid of me. Okay? And I saw that document a couple of years early. Okay, it was leaked to me by people. So I started making plans accordingly. Anyway, so when I left them. Okay, so I got. So one good thing that happened is my linear tech stock became worth more. So I sold that, and then I worked for a startup company that was doing they wanted a simulator like LTspice, except they wanted it for IC design, so that an application engineer could design an IC without actually having an IC designer. It's an idea whose time has come, but I lost confidence in that company's ability to do that. And when I joined that company, I had a contract that if I left at the time of 1 year, I would still own the code. They would not own the code. And for them to own the code, they would have to meet year 2 compensation commitments, and I would have to be there. But they were having too much trouble. They weren't going to be able to meet year 2 compensation commitment. So I left owning the code and the paperwork that I had in copyright. Then I spent a year or 2 just making models for another semiconductor manufacturer. I was very optimistic that was going to be the forever home for QSPICE. It was a Japanese company, and their product line was very in line with the sort of thing that an LTspice simulator would do. And in Japan and in Asia, they don't really spice enough. So I basically could give them the North American market. They had no market in North America or Europe, but I could give them that market. I think it was a grave mistake at their point that they didn't come through and decide to buy the simulator. Because they never bought the simulator. They bought models from me, and that was already a much more lucrative job than I had as a local license, just making parts with my simulator, but they never bought the simulator. And then Qorvo, I knew the management of Qorvo. They knew that the simulator existed, and they wanted to buy it. So Qorvo became the forever home for QSPICE. And they bought the simulator, and they bought me. So I'm actually, they bought me. I can't quit,
Property of core, I guess, essentially. Well, I'm glad you found a forever home for QSPICE.
Mm-hmm.
It's very nice. I have heard the words Marcus Aurelius software being thrown around a little bit. What's the story behind that?
So Marcus Aurelius Software is my company. It's an LLC, which is a different legal organization than a corporation. So Amazon is an LLC, and I am an LLC. Now the reason for Marcus Aurelius Software came from the fact that when I wanted to write a new simulator, the name that I wanted to give it, I knew people weren't going to like. Okay, I wanted to see. Here's the thing: I wanted to write an all-new simulator and completely rethink how to write a SPICE program. Just completely rethink it. And who rethinks things more than a despot? Okay, because a despot rethinks the very nature of the knowledge of good and evil. So the name for the simulator was going to be Caligula, which is like the worst person in history ever. Okay, and that also fit with SPICE tradition. The SPICE traditions is that they give it some terrible name. Like the first SPICE was called Cancer. And the dean of UC Berkeley said, you can't call this program Cancer, you have to think of a nice name. So they called it SPICE, because what could be nicer than SPICE? It was another naughty name, it was another in-your-face name. So they called it SPICE, and then Cadence did Spectre, who was the bad guy in the James Bond movie. So I was going to call my simulator, well, why mess around with these other names? Just call him Caligula, the worst person in history. Now that wasn't going to be a very popular name, okay? But to camouflage the fact that the simulator was called Caligula, I said, okay, I'll have, it'll be part of a tool suite, a whole bunch of different executables. And the whole tool suite we called SPQR, which is the name for Rome in antiquity. In fact, even today you'll see SPQR on bus tickets and city drains. So SPQR for the people, the Senate population of Rome. Okay, so, and then each executable is named after some despot. Like the GUI was Vespasian, because he built the Colosseum. When you're using QSPICE, you're sitting in the Colosseum and you see all the graphics. Vespasian was the GUI, the simulator was Caligula, and the post-processor was Romulus, who was broadly considered the last legal emperor of the Western Roman Empire. Now, so I had despots as the executable names. SPQR was the name of the product as a whole, and the the company was Marcus Aurelius Software. Marcus Aurelius was basically a good guy. He wrote a lot of, he was a Stoic philosopher, and he generally killed a lot of people. Okay, so everybody's got some bad stuff, okay? But he had, there was traits to his Stoic philosophy that fit well into QSPICE. That it doesn't matter, and the way I try to punch through how to do engineering is it doesn't matter if everybody else in the world thinks something. If it's wrong, it's still wrong. It's okay if you're the only person that thinks one thing. If you're right, then you are right. Marcus Aurelius believed that. It doesn't matter if 1,000 people think something. If it's wrong, it's wrong. And so that's the nature. That's where the name comes from. Now, Marcus Aurelius Software, LLC, still exists as a legal entity, but it has no assets. I sold when it came time to sell the simulator. We looked at this and says, oh, if you sell the whole company, then you have to deal with all this. You need lawyers. You have to deal with bank accounts, selling the bank accounts, selling the organization. It's easier to just, it's cheaper from a legal point of view to simply sell the assets and enter a contract to support them. But the LLC still exists. But basically, if nobody knows the name Marcus Aurelius Software, I'm okay with that.
I see.
And actually, the thing that I sold Corvo was called SPQR. And actually, there was another aspect of the naming. You can't trademark proper names from antiquity. Okay, not really. So, in giving it these names, I let any potential buyer, he got to name it. Okay, he would give the owner. So that was another. Huh?
So it ended up being QSPICE.
It ended up being QSPICE, yes.
Not a very bad name, but we had LTspice, and now we have QSPICE. Exactly. So QSPICE looks very different to LTspice. So did you have a specific source of inspiration for the new appearance, like schematic editors, yellow and...
So there was user interface should be driven by ergonomics. Okay? And in fact, when a user uses a piece of software, he may complain about it, but that's because it doesn't work like some other piece of software, which might be wrong too. It's not information. You can, if you give QSPICE to a bunch of beta users, you get a bunch of comments back, but it's not information. They're just thinking it doesn't work like some other tool they like. So you really have to look at it from an ergonomic point of view. What QSPICE tries to do is most of the modal dialogues are gone. There's very few modal pop-up dialogues. The problem with a pop-up dialogue is you place a resistor and you want to edit it, some dialogue pops up, you fill out the form, you say okay, and then your eyes have to move backwards. Your eyes have to move around the screen. And you don't want to do that. You want to look at something and edit the thing you're looking at right there. So that gets rid of almost all the modal dialogues. And it's one thing that modal dialogues do for you is they can confine your input to something that's permitted for syntax from the SPICE point of view. But instead of doing that, I use hints. If you're typing something in, it will show you the hints as to what that syntax looks like, which is the way a modern IDE. If you write software in a modern editor, if you type the first few letters of a function call or something, it's going to say, oh, maybe you're thinking this, and it will. It's like Ajax in a web browser. It shows you what it thinks you're doing. So everything is done with hints. So you get more advice, but there's fewer dialogues, and your eyes don't have to jump around the screen.
It's a bit more continuous. It happens as you're going along.
If you use it and your blood pressure is lower by 5 points, and all these stupid dialogue
That was actually the topic of the next question. What was the rationale behind it? But I think you explained that already.
Yeah. So. There's another, on the GUI, there's another sort of philosophical point of view, and that is that it's basically using gamer hardware. It uses the GPU, and the GPU does a couple of things. Some are really, really critical to the operation of QSPICE. So for one thing, it draws lines much faster than the CPU. Even an integrated GPU, integrated to an Intel chip, does much faster than a CPU. And so you don't have to compress the waveform data, you can just plot the data itself. Plus the simulator time step is such that I'm not embarrassed about the time steps I'm taking. I'm taking all the right time steps now. I don't have to try to hide what I did, So that's part of it.
Yeah.
But the other thing it does is it dithers the graphics. So you never see a pixel. It all is desktop publishing quality graphics all the time for every single line. It draws 100,000 faster than the CPU can. So, and so that does kind of tie it to the PC because graphics today is really driven by teenagers, video gaming graphics, gaming needs. That's what drives the graphics business, and that's a force that's bigger than me. So I just use that hardware. I use DirectX because that's where the action is. And people may say, "Oh, well, Linux is fast." No, it's not. It's not where it's happening. Okay. And so it does tie it to a PC and gamer hardware, but there's nothing I can do about that. It's a force bigger than me.
I see. Another very clear difference to LTspice is that LTspice has a main window, and the schematic editor and the plot window are within the one main window, but QSPICE splits it up. It is a bit slightly inconvenient from my point of view, although I have found a way to arrange stuff. We have talked about it on LinkedIn. So how exactly did that end up happening?
The floating window arrangement of QSPICE was an idea that I got from doing the Mac version. So there's a Mac version of LTspice that uses a different GUI, and I actually wrote that too. I know how to write Mac software. But the independent, the advantage of having independent windows instead of being one big frame, it's a newer interface, and it works well with multiple monitors. So that's really why it is. Maybe it's not as convenient on a notebook, but if you're sitting, with two 4K monitors like I do, it's much better.
That makes sense. That's not something I thought about. I have one big monitor, so I got quite used to the way LTspice works. So I think this is we just talked about it. I'm not giving you new information. I'm just complaining about the way the older software used to work.
Well, that's okay. You can always complain. It's all right.
Never mind. So, what exactly will you be focusing on in the near and far future of QSPICE?
For one thing, that the most recent changes that you see now is that there's tools being added to QSPICE to generate models of semiconductors. Like if you go into File, Model Generation, there's one for diodes and there's one for MOSFETs. And I'll be making more tools that also have more different types of MOSFETs. So you don't need the vendor models for MOSFETs. You can make your own, and they'll probably be more accurate. So you digitize the data. You'd be able to make your own semiconductor models. That's one thing that's happening. I'll be adding models for portable products. I spend time at other semiconductor manufacturers in-house teaching them how to make models because, like I said, Qorvo is interested in everyone standardizing on QSPICE because it isn't restricted in its license agreement. And, they just get some name recognition on that.
That makes a lot of sense. I think LTspice has almost been the industry standard. We will eventually be taught LTspice and Uni, but we've already used it, so that's not a big deal. And almost everybody ends up using it, even as a hobby, because it's not restricted. LTspice, no, that's something else entirely. I don't remember the name exactly, but that is limited in certain aspects, and the models are encrypted, which is a bit annoying sometimes. Microchip has their own Spice software and a couple of others, but LTspice is the name that gets thrown around most often.
It's the one that shows how the business model operates, but we've taken the business model to the next step with QSPICE.
Exactly. So the next question, in the words of the asker, might be a bit antagonistic. Will there ever be a time where we could possibly see the source code or parts of it? The question was...
The source code of what?
Of QSPICE or LTspice, or at least parts of it. The intention of the question was that the asker is very interested in developing Spice himself.
Who is?
The person who asked the question.
Okay.
A friend of mine. He does software stuff.
Okay.
And I have not exactly seen anyone saying, I want to be a Spice developer. So,
yeah,
a part of the source code might possibly inspire younger generations to get into something like that, which because admittedly, you are probably the only person in the world who knows how to write good spice software.
I'm probably the last one with a pulse, yeah. Maybe, yes.
The last one you say. So,
Yeah, well, I still have a pulse, so I can still write native spice devices. I don't know what hope there is of QSPICE becoming open source. The fact is, I wanted LTspice to go open source, and Analog Devices didn't like that idea, and ultimately what happened is that I left the company. Qorvo, if they make it open source or not, they would have to decide for themselves what value there is in doing it or not. I don't really have a strong opinion on that. The fact is that most people don't really, most electrical engineers are not interested in source code. They just want something that works. So the current situation is that if I just, fix every bug within 48 hours, then everybody has the best working version of QSPICE. And that's a good mode for it to be in. That's the healthiest and strongest technical point of view mode for it to be in. It should probably be in that mode for, I would expect, at least the next few years. So I think it's a pretty solid mode. There's really, I don't see a value to it. I've never really thought about it for QSPICE. If a license agreement is gone, it really didn't matter. If everyone can use QSPICE, even a competitor, even Qorvo, I don't know if they need the source code for, except to possibly recompile it and put a different name in the upper right-hand corner, or left-hand corner.
true. Well,
and also, one other thing is that because QSPICE includes C++ compilers and Verilog compilers, you want to put your mile in, you still own, you own your object code there, and QSPICE will just run it without giving you the source code to the simulator itself.
I see. So it makes a lot of sense from business point of view, let's say. But what would it possibly look like in 50 years when someone wants to make something better, because they will have to start from scratch, because they don't really have
in 50 years.
Platform to build upon.
In 50 years, okay. That's so far past my expiration date. I don't know if I have an opinion on that,
So
I have to manage my actuarial horizon, but 50 years is,
it's a bit too far ahead.
It's too far ahead for me to be concerned about.
So you're not particularly bothered about the people who might possibly come after you and who would like to improve upon spice.
Maybe it will be like the pyramids. People will come and look at the pyramids, look at it and says, oh, this must have been written by space aliens, Maybe people think the space aliens wrote QSPICE. I don't know what will happen.
Fair enough. That was a very interesting take. So, I cannot understand my own handwriting sometimes. This was written in the middle of a lecture, very hastily. So
you should have been paying attention to the lecture. Not
I should have been paying attention to the lecture. Yes. Yes. So what exactly goes on behind the scenes in a spice software? Not necessarily QSPICE, or just generally. What happens when you draw the schematic? What happens when you run the software? What happens when you plot it? And the general workflow, because that's not something people usually think about.
So when you draw the schematic, it's some CAD tool. The whole trick to getting that work right is that you have to be in an integer grid so that you know exactly what's connected and not. Okay. And that, I hope, is pretty straightforward because it all happens in front of your eyes. The difference between QSPICE and maybe older CAD tools is that, yes, it's not an integer grid, but it has a floating point zooming, so you can adjust the zoom continuously even though all wire connections are in an integer grid. Then that is turned into a net list. Okay, a net list, there's two types of net lists. Some are net-centric and others are component-centric. For PC board layout, they're usually net-centric. You say, this is a net, and this is everything that's connected to it. Here's another net name, like clocked out, this is everything connected to clocked out. That's net-centric. That's not what SPICE uses. SPICE uses component-centric. This is R1 connected to these two nets, R2 is sent to these other two nets and so on. That's component-centric. SPICE uses a component-centric. SPICE uses a component-centric net list. So it's R1 and then what's connected to R2 and so on. Now that net list defines the electric circuit, and it's what communicates the circuit to the SPICE simulator. The SPICE simulator parses that net list, and it's a fairly primitive. It has to be. It was written a long time ago, and it's a very primitive parser. But to add new things like equations, the parser's gotten more complicated because of its legacy of having been written in the 1960s, before there was very big compiler theory out there. The original SPICE parser, would treat parentheses, commas, and equal signs the same as the space. It wouldn't parse expressions. Okay. And there's times when the SPICE parser has to treat things like some people will write pulse, open parenthesis, and numbers, close parenthesis. The parentheses are white space. And so this legacy of very primitive parsing is something that's unfortunate in the way SPICE parsers have to work. I would prefer that people would stop using parentheses, equals, and commas as white space. It basically it makes you more error prone. You want to be able to see the stuff like the computer sees it, so that you're less confused by the way your computer understands your circuit. So you generally want to avoid any unnecessary characters. Don't use any of them at all. Don't even use leading zeros on a decimal point, because .1 is enough. If you don't train your eye to see .1 and realize that this is like a big thing, then you are working a more error-prone method. You need to just use the characters. Don't use extraneous characters. Then once the SPICE parses the net list, the SPICE server is going to solve that circuit. And this is where it starts now getting interesting, because SPICE looks like it's doing the impossible thing. It looks like it's solving the general nonlinear problem, okay, which is impossible, right? I mean, we've all had linear algebra courses, and we learned about rank and file and order and determinants and eigenvalues and eigenvectors, and more important to how to solve a matrix. But on the last day of class, the professor turns around from the blackboard, looks at you and says, "This is the way you solve a linear system. If you have a nonlinear system, we're going to wish you a lot of luck with that, okay? But there's SPICE doing what appears to be impossible, okay? Well, it's doing that because it's not actually solving the general nonlinear system, it's solving a very specific nonlinear system, and that's one that has IV curves that are continuous in value and slope, okay? And if your IV curves are continuous in value and slope, then you can potentially solve it with something called Newton iteration. And Newton iteration is an amazing thing. Yes, it made some Isaac Newton and Ralph Solomon. Okay, the Newton iteration says this. Okay, you've got this nonlinear system. I can't solve it, but I can approximate it. I'll approximate it as a Taylor series, but a multi-dimensional Taylor series, and I will keep only the first two terms. So my approximation is, exact about the point about which I linearize the circuit, and it has the first derivative. So any of the curves are approximated with a straight line. So it's exact at where the thing was extracted, and it's close away from it. Now, if you solve the linear circuit, and that linear circuit, the solution of the linear circuit is the point about which you linearized it, you have the answer. Because your approximation is exact there. It's not an approximation, that's the solution. You've just proved you found the answer. Newton iteration results in numerical proof that it had the answer. Now, if it's not then it will use that new solution to expand the thing again and iterate towards the thing. The net result is it takes about 3 times longer to solve a nonlinear system than a linear system because it makes a few iterations. But it's only a few. If you're within 1%, your error is second order, so instead of being within 10 to the minus 2, you're within 10 to the minus 4. Do one more iteration, you're within 10 to the minus 8. You're probably good, but if you're not, do one more, you're within 10 to the minus 16. And that's as accurate as scoring the computer anyway. So it's an amazing thing. It's blindingly fast. It's basically the FFT of error minimization. So it's that's how the SPICE itself works. Okay.
How about the plotting and the measure command?
Okay. So the once it solves the circuit, after every time point, it writes at the disk. And then in QSPICE, there's a different process which will read that file, and that file will be updating. We'll keep incrementally read that file and plotting it. The plotting is, the 2D plotting is not that complicated. You plot from here to here. It's not that complicated. A routine. You have to deal with plot labels and plot label sizes. To get good speed, you need to use something. You need to use a DirectX interface. You can't plot with the CPU. You use DirectX,
which is much easier.
And DirectX is basically living off of teenagers' video gaming needs, and to do video gaming, you need to draw a lot of triangles very fast. So that's the problem they solve. They can draw triangles real fast. In a line is 2 triangles that look like a rectangle. So that's how it's clunky. That's the fact that because teenagers need to draw a lot of triangles, I just draw 2 triangles for every line, and that's faster than just drawing 1 line. Because of the market situation where it drives the graphics technology.
Exactly. The next question is also somewhat related. LTspice does give you a few hints now and then as to what's going on behind the scenes. You come across phrases like the determinant was non-zero or 0, and sparse matrices and Newton graphs and iteration. So I think that's all part of what you explained. But I'm particularly interested in what exactly the determinant equals 0, like in the sparse matrix numbers.
I don't know that I ever report that a determinant is 0.
It might have been non-zero. I might have written it wrong. It just says determinant equals 0. Well, I did write this off the top of my head, so I could be wrong there.
I don't know that anywhere I report the determinant being 0, except possibly in analyzing a transformer with many mutual inductances. So, say you have 3 inductors, L1, L2, and L3, and you say that L1 is connected to L2 perfectly, and L1 is perfectly connected to L3 perfectly, but L2 is not connected to L3. That's impossible, and it actually violates causality. You can't solve that circuit. So QSPICE will look at the eigenvalues of the matrix, and if any are 0, it will tell you. If any are negative, it will tell you the eigenvalue of your eigenvalue for coupling coefficient is negative, which means that you have a non-top causal transformer. You can't solve it. So that's the closest place I know of any error message like that in QSPICE.
What about the sparse matrix?
What about it?
Well, I've come across the term relation to SPICE, so I was hoping you could tell me a little bit more.
Okay, so yes, it is a big part of SPICE program. So there's an interesting thing. So in school, we learned about solving matrices, but it turns out that most matrices are very sparse, which means almost every coefficient in the matrix is 0. Okay, and SPICE, if you exploit the fact that you know the matrix is sparse, 2 things happen. One is you need very little computer memory to store the memory. You can only store the non-zero elements. And the other thing is you can solve it very fast because you only have a few floating point operations to eliminate each unknown. Now, to appreciate how sparse a matrix is in circuit simulation, it's unbelievably sparse. So consider a schematic that consists of a fishnet grid of resistors. Now that's dense, okay? No, you only have conductivities from each adjacent matrix to another. If you write out that matrix, you never have, I minus j, the absolute value is only 0 or 1 for the whole thing. It's just a band. Your matrix is only got a few black lines along the diagonal, and that's it. Only if you had your matrix not just a bunch of a fishnet grid of resistors, but this resistor going to that one, and to that one, and to that one, and to that one, and only which you can never even draw, But basically, matrices are so sparse because the schematic has more white paper than black line paper. That's why they're extremely sparse. And exploiting the fact that it's a sparse matrix makes it much faster to solve and needs much less RAM. It is a very important part of what makes it possible to solve large circuits in SPICE.
The next one, once again, goes back to the topic of the user interface. There have been occasional complaints, quite frequent complaints about the keyboard shortcuts in LTspice. They did fix that with the latest one, but was that informed by the way things were done maybe 20 or 30 years ago?
Okay. The keyboard shortcuts in LTspice were the same ones that were used on a CAD tool in-house at Linear Tech.
I see.
Okay, and that CAD tool was written in the 70s. They use the same schematic and the same tools. Now, in LTspice, I managed you can reprogram the keyboard shortcuts. Yeah, I didn't like the keyboard shortcuts either. Just compatible with a different CAD tool. In QSPICE, I use entirely different keyboard shortcuts. They're not programmable, but they make more sense now. The problem with programmable user shortcuts, if someone asks for help, I can't type on their computer if it's different shortcuts. So I simply try to use better choices so they wouldn't have to be programmable.
I see. And people do mention very often that the software itself, be it QSPICE or LTspice, looks like it came out of the late 90s and early 2000s. Is that just personal aesthetic choice on your part, or?
Well, so the user interface of LTspice, it was written in the 1990s, and yes, people like to complain about it, and I appreciate all that, it's very dated, but at the time it was written, it did define the state of the art. Okay? I mean, one of the reasons why I did so many seminars is I would travel around the world and say, look, you can draw on this thing faster, you can with pencil or paper. That was a fact because of the amount of progress I had made in the user interface of LTspice. Now with QSPICE, when people complain, it's because it's not what they're used to, because they haven't seen a tool. I mean, it's a more advanced user interface than you generally see, especially in electrical engineering, because electrical engineering just isn't a hotbed for graphics and user interface. It just, I hate to disappoint you, but it's not. And QSPICE is a much more modern, up-to-date user interface than you see in the CAD tools that electrical engineers use.
That is true. I think most of the complaints are indeed from the younger generations, let's say, who are quite used to minimalistic and flashy interfaces.
Well, QSPICE is minimalistic. It doesn't use dialogues or anything. Everything's edited in place. It doesn't waste screen space. It is a little sensitive to maybe older, smaller monitors to some extent, but it is rather minimalistic and.
I think the lack of color schemes is also something you hear about, but as far as
you can choose every color. In QSPICE, you can choose every single color. There's no reason why you can't change. You can change the color of anything. Any text color, any line, or the background, you can change all these colors to be different preferences.
But it is not defined in a certain file, or it is not part of a default list of themes you can select. Because editing each element can become a little painful sometimes, because you have to do them one by one.
You have to do them one by one. I don't have themes set up, but they are stored in the registry. So if you go from computer to computer, they will follow your preferences. So I think that's done the way it's supposed to be done on Windows OS.
So it's good enough.
I think it's just done the correct way. It's not a question of being good enough. I think it's actually done correctly.
Good to know. Is there something that is possibly limiting the SPICE software you write, something in terms of computing power, or maybe something that might possibly require a few more Fields medals to be able to...
A few more what?
Fields medals. It's one of the highest...
Fields medals?
Yes, it's the highest mathematical
I see.
medal that's given out to people under 30, I think. So the question is actually if there's something mathematically or computationally limiting the SPICE you're writing right now. Something that might possibly help you greatly in making it faster or easier for that matter.
I think that SPICE was successful because it combined sparse matrix methods, neat iteration, and implicit integration of differential equations. It was kind of a perfect storm that made that you could solve for the first time large circuits rather robustly. And to the best of my knowledge, I'm not anticipating a breakthrough new numerical method. I'm really not. Okay. There are methods you can use to you can use this and add other features to it, like you can break the circuit, you can partition the circuit so that there's different parts of the circuit are solved by different computers and we talk to each other. But which to some extent I do with the mixed-mode simulator. The mixed-mode simulator was a digital simulator, which is completely independent from SPICE and doesn't get into an argument about the concept control about rather what I think is an optimal concept control between the SPICE and the digital simulator. So I don't think that there's a real, I don't think there'll be a watershed moment of all the new numerical methods for solving generated log circuits. I think they can get that right. There's a lot of things wrong with the way they're implemented. There's a lot of bugs in SPICE programs, and those need to be fixed, and they cause problems. But as far as the most elementary, fundamental numerical methods that are used, I think they're pretty good. I guess one thing that I would like to see, except I don't think it's possible, is I would like to see an FFT that didn't have equal space-time steps. If there was an FFT with the logarithmic space-time steps, that would help a lot.
It is extremely interesting that you should mention that. The same person who asked me if you could possibly release the source code because he's interested in developing SPICE, he did prototype and implement a nonlinear FFT. I don't remember.
What does he mean by nonlinear?
Well, the plotting, it's not equally spaced time steps, but it's sort of nonlinear.
It's logarithmic time steps?
Something like that, if I remember correctly.
Okay, I see. I would be interested in that. I don't think, I've looked at it enough to think that it's maybe not so possible.
I might be once again remembering something wrong, but this sounds very familiar.
But as far as nonlinear, it can't be nonlinear, because if you're going to set up a frequency domain, it's linear. Otherwise, it doesn't have a frequency domain. Otherwise, you can't describe it in the frequency domain.
The plots he was able to generate for noise spectrum density were essentially smooth and flat, because you're used to having FFTs being very spiky without smoothing. So he found a way to do it at certain points, and those points were not linear, so you could plot them on a log-log scale instead of having to go through each and every single point, I believe. So it's interesting. I could show you the link if you have a little bit of time.
You can email it to me.
Definitely. Have you ever discovered a situation or a problem where SPICE was actually not particularly helpful? In terms of
I got into an argument with the wife, and I tried doing a SPICE simulation, and I just couldn't make any progress with it. So it doesn't help me when I argue with my wife. It just doesn't help at all.
I see. So the indirect implication is that it can basically help you with everything electrical engineering.
Except arguments with my wife or my cat.
Mm-hmm.
My cat won't listen to me either.
Very well. That about sums it up, I guess. I am also generally interested in knowing Oh, right, the most important question, but let's get to that later. Well, one of the most important ones. You did mention multiple places that the code generated by the C compiler and QSPICE generates native Intel object code. What exactly does that mean?
Okay, well, when you type in C and you compile it, it's like you're writing an assembly language. You end up with object code. Okay? That's what happens with the C compiler. It makes object code, Intel object code is if you had written it in assembly language, and then it executes that object code during the simulation.
So it's essentially generating assembly that can directly be run without having...
I'm using assembly language and object code as synonyms. They're not actually synonyms, but it's, okay, when you compile a program, you have object code. Okay, object code are the bytes, the actual, the computer instructions is, so many bytes of computer instructions. That's what happens. It compiles it to a DLL, and it executes routines in the DLL. So in QSPICE, you draw a symbol, you can type in some C code, you compile that to a DLL, and then the functions in the DLL are called by QSPICE.
Got it. So it ends up speeding the process up.
Oh yeah, I mean, if you want to simulate digital logic, it will evaluate faster in QSPICE than it does in the hardware. Yeah, it's a big deal. Yeah, it's a real big deal.
QSPICE does feel overall finished, if I can use that word. It has a certain polish to it that LTspice I feel somehow lacks. Like everything about it was very well thought out, I can say. Exactly, like you said, it's something that was a result of. It is the thing you would have written 25 years ago.
Yes, if I knew that. And if the hardware had been available.
Exactly.
And if the numerical methods I'm using were available, they were not.
I have to admit that I do like the in-place editor of voltage sources and stuff compared to the dialog box, although some people feel differently, but that's just the way QSPICE works. Get used to it. The question I skipped over was...
This is the most important one you said?
Well, one of the most important ones. It just struck me as being something that I would definitely like to ask you. QSPICE and LTspice are essentially Windows only, and LTspice does have a Mac version. How did that come to be? Users
I tried to address that. It deals with the graphics. I'm using, so graphics today is really driven by video gaming needs. Okay, teenagers needing better graphics for their computer games. That's what drives the business. And that's the hardware I'm using, and that exists only on a PC. Okay, so, there's no emulation that will do it on a Mac. Macs have, so there's two other platforms of some interest. One is Mac and the other is Linux. Now Linux, graphics is a mess on Linux. Okay, you don't have much there. On a Mac, graphics is getting better. So when 10 years ago, everybody thought the Mac had better graphics. Well, actually it was a lot slower than a PC. But people were not using the most recent graphics library on a PC, so it looked like garbage. And the Mac was great because it was doing dither graphics, but it was dithering with the CPU. But the PC, you could have dither graphics and use the GPU, and it was 100 times faster than the Mac. But people weren't aware of that because there wasn't any software that used it. Today I'm using up-to-date libraries and the hardware that's on a PC. There could be a Mac version and it would be able to handle the graphics well enough. The GPU of a Mac is not as good as what you can get on a PC, but it is good enough. However, the Mac is now on an ARM processor and not an Intel processor, and that means that you don't have an 80-bit data type. And they can't do floating point math as accurately as a PC, and that would be a hindrance at times. And in a PC, you guys will give me the answer using 1,000 times more, 4,000 times more accurate internal calculations and see if it runs better. So the Mac version can't be as good as a PC, but the real problem would be the SPICE part, not the graphics part. On Linux, I have not seen good graphics on Linux. I just have never have. and I've never seen, there's no good DirectX implementation nowadays, so it doesn't run. There's nothing I can do about it. It's just something, it's all driven by teenagers' video gaming needs. And you know what? Teenagers need faster computers so they can score more points, so they can buy more weapons, so they can kill more space zombies. It's okay. It's all in the name of progress, So, and that's what drives the graphics business, and I just use that. Yeah, it used to be that, like 10 years ago, they talked about this being a gaming computer, and then they had to make, it's gaming or scientific calculation, because, some people had to do scientific calculations to use gaming computers.
Yeah.
That's what we use if you don't know it.
Definitely. So it was more of a graphics decision than anything else.
Well, graphics and the Intel having the 80-bit data type. So there's two things that really tie it to a PC. Well, it ties it to Intel or AMD, but not ARM, because of this 80-bit floating point type. And the graphics really ties it to a PC, though the Mac probably has good enough graphics today. The ARM processors. See, Mac didn't used to use a graphics processor. They used to have a CPU. And now they have a GPU. So I strongly suspect that a Mac's GPU is good enough for rudimentary LTspice simulations.
So if there is ever a time where Linux figures out the graphics mess, would you be open to writing or rewriting LTspice?
I would at that point, but I would say I would be open to considering it. Right now, I just swap the idea away that, I wish. People ask the question, just don't understand the technology. So right now, I just kind of swat it away. But if it could do the problem, then I would consider doing it. But it would have to deal with the fact that I would have to look out at this trade show and see people using Linux, and nobody is. There'd have to be a reason to do it. But right now, they don't have the technology to do it. The technology is not there. If the technology was there, then you would make a decision. But right now, the decision's made before you start thinking about it.
Right,
but I've never seen a person at this trade show using Linux. Okay, not one person. I saw a couple of Macs, but that's it.
It's very interesting. So I think we've been at it for slightly more than an hour.
Alrighty.
So Mike, thank you so much for talking to us.
Yeah.
It was a pleasure and an honor. Yeah, that's about it.